All right, I'm live with Assimilate-Haskell. The idea here is every couple weeks or so, I dive into the Haskell programming language and then get started with, doing things on really a functional programming approach. And so Haskell is kind of an interesting language because it hasn't really gotten widespread adoption, but a lot of people respect Haskell. So, what I'm going to do as well is I'm going to use some of the emerging tools that are available for the modern development lifecycle, including Copilot, which I think is going to play a big role in me building really cool stuff with Haskell. And so, in order to do that, what I'm going to do is I'm going to go ahead and share my screen. Let's go ahead and get this started here. And I will present this, go to share screen, and get this cooking. All right. So, as I mentioned before, the Copilot tool and dev container with GitHub is going to really help me out here. I don't yet know what that's going to look like, but let's actually go through it together. So if I go in, I dive into repositories here, and I say new repository, one of the things that I can do is actually go ahead and say assimilate Haskell. So let's go ahead and do this, assimilate Haskell. And I guess it's already up. So maybe I've already done a little bit of Haskell here. Let's go ahead and see if I can find that assimilate Haskell. Let's try that. Oh, there we go. So I don't know what I did before, but I think I have something cooking here. It's been a little bit of time. And let's look at some of the key components of how I would get started with Haskell. One of them is dev container here. So notice here I've got a Docker file, and basically I've got Python in here just in case I need it. And then I also have the ability to potentially pre-build this environment, which is a great feature for actually getting fast response time. So notice we have this pre-built setup here. So looks like I'm actually ready to go here, which is awesome. So I'm going to go ahead and go to code, and I'm going to create a new code space. So one thing I'll point out here with code space is if you're using a compiled language like Haskell, one of the things that's kind of fun is that we can use a very powerful machine. And so this is one of the advantages of dev containers, is that actually you can go ahead and configure a very powerful environment. In this case, we have 16 core right here. And if I go ahead and I say create code space, this will go ahead and launch a very powerful 16 core environment for me to compile Haskell. So anytime you're doing things with a compiled language, it is a good idea to go through and build out potentially the most powerful machine you can get your hands on with, to some degree. Like, obviously you don't want to spend $1,000 an hour or something, but if you can get a more powerful machine when you're doing compiled code, it's great, because the compiler is really what takes a lot of the time. It's beneficial, but it is important to be aware of that. So we see here it's kind of getting set up here, and we're getting all this stuff cooking. The other thing that we can do is I can pull up a like a quick Haskell guide. And so let's see what we can find here. If we just type in Haskell, haskell.org is probably a good place to take a look at. And you can see here there's some documentation. That's typically how I get started, is I look at the official documentation when I'm learning a new language. And we see here, this is if you're new to Haskell, well, that's what they tell me. So let's go ahead and use it. So we have introduction to Haskell right here. What is Haskell? And we can see that there's some nice things here that potentially I can riff off of when I'm building things. So now that I've got that, we should be able to in just a second launch this code space. I guess it wasn't totally built because it's been a while since I logged into this, but you can see here it's installing this, which I believe is the compiler for Haskell, right? So yeah, the Glasgow Haskell compiler. We can see that the latest release. Let's look at the latest release here. So home was 944 was the latest release. So maybe we even pull in the latest one as well. So we have a couple of good resources. We also could take a look at Microsoft Learn. I don't know if Microsoft Learn has the ability to do anything with Haskell. I don't know if that's too exotic for them, but let's go ahead and look at it. Haskell and nothing. Nothing. Well, let's see. No, here we go. We have a little bit of Haskell here. So these are videos. I don't know if there's any tutorials. I can type in tutorial, but I always like to have a few different references. What's this? No, that's a video as well. Tutorials and walkthrough. Tutorials. It would be nice if you could show maybe just documentation. Here we go. This looks kind of new. HPC. Yeah, I don't see anything off the top of my head, but we'll come back to that. But once this thing launches up here, I'll spin back into Haskell. So we got that one. Maybe one other one is let's look at the Haskell documentation and see here we go, a gentle intro to Haskell. This looks pretty good as well. This one looks a little bit cleaner to look at. And I think functions is probably where I want to start, is to build some kind of a function with Haskell, because I feel like the function is really where I can map my mind around something, right? Is once I can build a function in a language, I pretty much get a good vibe for it. And so again, we'll just wait for this to install here. I guess I could even look at what I put before. So let's see. So I downloaded Haskell, so install and get started, and I did which GHC, and it showed that it was in here. And then we can also tell what version, which is right here. And then I wrote a hello world Haskell. I compiled it and I ran it. Okay, so that's actually kind of useful. It's interesting because I did so much stuff in so many different languages. I forgot I even played around with Haskell, but it looks like I did do some stuff a while back. And then I put a note to myself to go through this. Oh, okay. Well, then let's follow my notes, since maybe I knew what I was talking about before here. So we got, okay, we're back. We're in business. So let's look at what my README told me to do before. So it said which GHC, which GHC. There we go. Oh, is it not in? I thought it was inside of this code space. Let's double check. Oh, there we go. No, I don't know why that's not showing up. Huh. Maybe I need to put that in my bash RC. But first, let me just double check what the version is. It's 925. There you go. You should see this or something similar. So let me put this. I'm assuming I need to put this in my bash RC, which probably is a good idea. So if I said vim bash RC and I go to the bottom, yeah, see, this looks like it should be there. Um, Not exactly sure why that doesn't show up. Maybe you can source it again and it should show up. HRC. If I type in DHC. Huh. Yeah, some kind of an environmental issue here. But I mean, I guess I can fix this kind of easily by just editing that bash RC. So let's just do that. I don't know if this is the proper way to do this, but I'm just going to say alias GHC equals, and we'll just do that, right? So this will basically create an alias for the Glasgow compiler. And if I again say source.bash RC, there we go. Okay, so if we say GHC -- version, wait, GHC here, what? Oh no, GHC version. There we go. Got that working. And then you can see I have a hello here. Choose automatically if you're in doubt. Okay. So maybe I didn't have some kind of auto tool set up for code spaces, but let's take a look at the extensions. like, is this been added? It looks like it already was. I don't know if this was in my dev container. Oh, it's already included. Okay, good. And then Haskell syntax, it's already included. So it looks like I did get this environment pretty well set up. So maybe I don't need to do much to it. But again, here's the hello world. And then I should have made a makefile. I've got some makefile stuff up in here. This doesn't look very Haskell-ish, but I guess there's a little bit of Haskell. If I say make compile Haskell warnings, there we go. You can see that it compiled that hello. But I think the easier way to temporarily compile with Haskell is to go and just type in GHC hello, right? So pretty simple, just GHC hello dot HS. I keep on saying GHC hello dot HS, right? So that was pretty easy. So if I remove, and if I say hello here, there's a compiler. And if I remove that, I run it again. There we go. So it made a new copy of it, right? So we know that works. The hello world works. You can also run this, which I assuming must be able to kind of interpret what's happening, which is kind of nice. So if you don't want to have a bunch of binaries created all over the place, that's a good way to do it. And then if we want to go to this, go to GHCI, which is nice, we can actually do some like interactive stuff. So if I go through here, there you go, and say main, right? So it's kind of cool. Exit. I don't know how you exit out of here. Let's see. What are my notes here for how to exit? This is always the most difficult stuff. Like the easy. Hopefully, I was smart enough to figure out how to quit. Let's see. Control C, Control quit. Now I'm gonna have to Google this. We can say, oh, to quit. Do you do this? Quit. Huh. Yeah, let's see. Quit GHCI. Let's figure out how to do that. Quit. Control D. Okay, Control D. So Control D. There you go. So that's important to put in here. So to quit, but like note to quit, do Control D. Control D. Perfect. Okay, so we got that. Looks good, and we can. I think I have enough to kind of play around with stuff here as well. And I did some Haskell things. So let's build out a lesson too. So using Cabal. So I don't really know anything about Cabal other than I've heard kind of some good things about it. Like, hey, it's an awesome package manager. You know, like so. Let's learn, right? So I'm going to go ahead and walk through Cabal. It seems like you really don't want to be doing things without a package manager, right? And so again, I've heard some really good things about this. So what is it? What is this? So using external package manager by default, it can only load packages that are included, but users of Cabal install can install packages very easy. So this looks cool. It looks very much like the Rust cargo type system. And it says the modules will be ready for import. It says how to create a proper module, how to build it. So I'm liking this. I'm liking this a lot. And now I just need to figure out how to create a project. And so, okay, let's do this. So let's go ahead and do a make dir Haskell project. So let's try this. So let's try our hello world here. So I'm gonna go through and say, okay, step one is make dir Haskell project. Let's go ahead and do that. All right, make dir Haskell project. Assuming then you would CD into it. right? So we'd say cd into Haskell project. There we go. Perfect. Okay, so next, cd Haskell project. Okay, there we go. cd Haskell project. And if I say Cabal init interactive, it will generate a simple project with sensible defaults. I love this. This is so much like Rust. It reminds me of some of the cool things that Rust does. So you go through here, you say Cabal init interactive. Beautiful. Should I generate a sample with defaults? Excellent. Look at this. I love this. So now if I go to Haskell project, again, it's interesting how similar this feels to me to actually to Rust. And look at this. See, we have this like structure here with all this cool stuff, and it shows me everything. So I'm getting a good vibe here. I'm really liking this style here for Haskell. And then we have the source, which again has like a library file, and then we have the app, which is going to be your main file. So again, it feels so much like Rust to me, and maybe they are like sharing ideas with each other. And where what I like is to have a library that does the logic, and then I have the main that invokes the function. So it looks like that style works quite well for Haskell. So I'm loving this. And so the next thing you do is you do Cabal build. Okay, let's do that. Now, for me personally, one of the things I like to do is that even when I'm using multiple languages, what I like to do is actually refine things so that I always use a makefile, because I can do the same conventions across many different languages: Python, Rust, Go, C Sharp, etc. And so Haskell. So I'm going to do that. I'm going to go ahead and say let's let's CP the makefile above to here, and I'll just tweak it. So what I can do is I can just get rid of the install. In fact, what I could even do is let's just keep it simple. And we really want to just do basically a build, right? So let's just say build. There you go. Exactly. Cabal build. Now, because I have Copilot enabled, I've got like a performance enhancing substance for my brain, so it can build this very very quick. And so if I type in make build, what do we get? There we go. We can do a Cabal build. It resolves dependencies, goes through, and I'm assuming, yeah, it's going to create some kind of build location that actually should have a binary that I could run, which looks like I don't yet know how this works, but we'll find out. So, oh, I see. This is, man, it's so funny how similar this is to Rust, which is comforting, right? Because I love Rust. And so now we can do Cabal run, right? So if we do this, we can say make run. Perfect. Cabal run, up to date, hello, Haskell. So the reason I like the makefile is that it creates this really simple way to invoke things in a uniform way across multiple languages. And then I always know, no matter what language I'm in, if I kind of forget the syntax or something like that, it's like, oh, I just do make build, or oh, I just do make run. And so I think this works very well with Haskell, like extremely well, in fact. And so we can put the notes into the README, and we can just do what I did next. Is then you would say make build, which is Cabal build, and then do make run, which is Cabal run. There we go. Perfect. So now that I've got that hooked up, what else can we do? So let's look at the dependencies here, which I think is a great way to get started. So let's add a dependency and adjust our library module. So we're going to open up Cabal, and let's go ahead and do that. Let's look at the Cabal file here, which again is a lot like cargo.2ml. And if we go here, we can say in the library section, the interesting places are expose modules and build depends. To add a dependency, it should look like this: build depends. Okay. Now open the source and change it to this. Oh, okay. So we're going to basically create a function because I don't think it had a function in there before. So we see that default language, got that. So let's go to source my lib here, and we're going to tweak it so it looks like this. So we have the sum function, which list directory source, which would list, I guess, in here. Yeah, I don't totally understand this. This style is interesting to me, but we'll figure it out. And then to add a module to your package, add expose modules like this: mylib and otherlib. Oh, okay, interesting. I like this. So let's go to here and let's go to expose modules. Oh, so we're going to tweak it so it's got two things now. I see. So it's going to have mylib and otherlib. Okay, I think that looks right. And let's double check. Does it say, yeah, expose modules? And then we're going to create a file called source other libs with this content. Okay, let's go ahead and do that. We'll say touch. And then instead of the other lib, we'll put this content inside, which should look like this. There we go. So set module name to Haskell. And there we go. And let's just say, I'm assuming we're going to compile now. Let's REPL. Interesting. So you can do REPL. So Cabal REPL, and we can just play around with it. Oh, I love this. So we can put that note here, and then we put some notes like, add more files, and then tweak the Haskell project.cabal, and then open up REPL, right, which is this. Which is, I love this style because this is kind of similar to how I would do something in Python. Let's try this out. Boom, look at this. Uh-oh. So we have an error here. Did it, I think because I need to tweak this a little bit. Let's see here. What do we got different? We got this source directory, base builds. Could not load module system directory. It's a member of a hidden package. Yeah, I don't know what that means actually. So this seems like common stuff. Control D to get out. That let's double check I followed everything correctly. So let's add a dependency. Open this up. The interesting parts are expose modules and build depends. It should look like this. Does it look like that? Let's look at our build depends here. I think that's different. Build depends looks different. So what does that do? Well, I think the biggest difference is this, which is a little bit goofy because it seems like error prone to do this. Like, yes, I mean, it would be nice if I could format this or something, but let's try again. Oh, there we go. So that was it. Now, this is kind of magical to me. It's like I have no clue what that does. Don't know why it worked, but maybe directory is like a systems, like a standard library package that lets you do listed directory. That makes logical sense, right? I bet you that's what it is. It's kind of it's part of the standard library. Okay, here we go. So we can hover over it and it says list all entries in a directory with. Okay, so that is what it is. So I had to include. I guess the issue is that this is this is basically pulling in an external config, um, right? In the external config or the external library is different the than like the expose modules, right? So this is the code I write. This is the code that's external to my project. Okay, I think I got this now. And then again, we go through here. We say 2 modules are loaded, and you can see that both are actually loaded, right? So this looks good. This looks like a nice, a config here or whatever, and we can look at the output and then go from there. We can say bash, right? So not too bad. And now what I'm going to do, I'm going to do Control D to get out, and I'm going to say make build again, and it looks like it compiles, and then I can say make run, and there we go. Hello, up to date Haskell. So I think this is a good start. This is not bad. It's making me feel like there's a lot of potential to build out something in Haskell using this style. And I think the next lesson, let's go ahead and check this in. So I'm gonna go up a directory and say get status. Hopefully, the thing I always am bad at with a new language is I don't want to check in binaries. And I don't know if I was smart enough to create a git ignore that's, well, hopefully this works. The git ignore looks hopefully good, but it's possible if I create subdirectories, I can check in garbage. Well, we're about to find out. And I'm going to say get add, readme, get add Haskell, and say get commits, adding Haskell projects. There we go. Looks good. I don't see any binaries checked in, just regular Haskell files. Okay, so the next thing that I'm going to do is I'm going to put a note to myself about what to do next time. So I think this is kind of important when you're, because again, it's been months since I started working on this, is I forgot even what I was doing. And if I wouldn't have put these notes in, who knows? I would have lost a lot of progress. So it's always important to put the notes in. I'm going to say lesson 3, build a working Marco Polo command line tool. Right. This is kind of one of my go-to tools. And so let's like use Cabal, and let's put some notes to myself, like use Cabal and build out a working command line tool. Command line tool that takes in Marco and returns Polo. Right. I got a great vibe here that I think I'm in a good space. And I'm going to go ahead and check this in, the notes, and that'll do it for this particular Haskell lesson. In a couple weeks, I'm going to build on this lesson. So I've been changing things up so that every 2 weeks I do a different lesson. But see you in a couple weeks if you're interested in Haskell. There we go.